Will now be recorded.
Hey, hello everyone. Very good morning. In today's session, we'll try to understand about one very important service in AWS, that is AWS Lambda. So in today's session, we'll try to quickly discuss about what is this AWS Lambda and what are the advantages of using AWS Lambda and what are the features of AWS Lambda, and in what scenarios or in what use cases we can use this AWS Lambda, and how this AWS Lambda will work. And we'll try to take one sample use case or a sample scenario or a requirement we can think of, and we'll see how to create a Lambda and how the Lambda will get triggered with some kind of a use case or a requirement. We'll try to understand. First of all, you can think of this Lambda as a function as a service. So if you are already aware about cloud computing, these cloud computing providers are a cloud service providers. This cloud computing or a cloud service providers already providing various services under different service models like infrastructure as a service such as EC2, EBS, VPC, and we have platforms also as a services, and we have software as a services, right? Similarly, this function as a service, right? this aws lambda this AWS Lambda, you can think of a function as a service. First of all, what is this Lambda, right? How this Lambda will work, we will try to understand. You can first we'll try to understand what is function as a service. You guys already aware about like infrastructure as a service, platform as a service, similarly, right? Software as a services. Now let's understand about function as a service. This function as a service is like a serverless function as a service is like a serverless cloud computing model. You will only develop some kind of a code, some kind of a function, and the cloud provider will run them on demand. So without creating a server, so this is like a serverless computing, serverless cloud computing. Basically, we no need to create a servers. You no need to create a servers for running some kind of a code, some running some kind of a function. So you don't manage the servers and operating systems and scaling. All of that is handled by the cloud service provider. But in order to run any code, any function, or any script, right, you need a servers. Understand this. In order to execute any piece of code, in order to run any piece of code or any function that will perform certain task, you need a servers. But this instead of you create the servers and instead of you manage the servers, right, every time, like whenever you need to execute that function, that time itself, in the background that cloud service providers will create some kind of a computing, and they will execute the given function or a given code. Then the computing resources will be terminated. So what does it mean? Basically, here serverless cloud computing, in the background there is a servers, but the servers will be created whenever we need to execute that function or that code. By the cloud service providers, they will create and they will execute that code and they will terminate that infrastructure. We don't need to create a servers, we don't need to manage the operating systems or scaling. All of that is handled by the cloud service provider. We will just upload our code to the cloud service provider, and they will run whenever it is triggered. Basically, in order to run any function, instead of running the server 24 bar 7, instead of creating one dedicated server, instead of creating a dedicated EC2 instance, or maybe instead of having a dedicated containers or a clusters, Kubernetes clusters like that, only sometimes you have to execute that code, sometimes it has to execute that function. But you no need to have a 24 bar 7 a dedicated systems or a containers running. So whenever that code, that function has to be triggered, that can be triggered using this function as a service, like a serverless cloud computing model. So we no need to create a server, say dedicated systems, and we no need to have those systems up and running 24 bar 7 365 days. Whenever the servers is required to run that code, that time only it will be created, and again it will be terminated after running that code. Again, whenever that code needs to be executed, again the cloud service providers will create a computing resources in the background, and again the code will be executed, and again once the code is executed, the cloud providers will terminate that computing resources, like a functions as a service. So here it's like a serverless, but in the background there is a servers, there is a computing resources. All of that is handled by cloud service providers. So basically, we no need to create a servers and make that servers available 24 bar 7. So here billing is also, we can save some kind of a money also, pay per execution and duration, right? So whenever that function is getting executed, how many times the function is getting executed, and how long the function is executed using this serverless model, only for that time only AWS will charge. And again, when that function has to be executed, that lambda, we call it as a lambda functions, right? So that when that function will be executed based on the event driven and short lived. So based on some event, the lambda function gets triggered in the background. In order to execute that function, AWS will create a servers, and that code will be executed there, and once the execution is done, it will terminate. So basically, you can think of this lambda like a function as a service, serverless cloud computing model, where you will only write and deploy the function like a small code, and the cloud provider will run them on demand. So basically, what are the characteristics of functions as a service? This AWS Lambda falls under function as a service, right? So event driven, the characteristics of function as a service is like a event driven. Functions are executed. Function means like a code or a script. That function or a basically code is executed by events. So this lambda supports various events, event driven execution. So functions are executed by the events like AWS events. Suppose, just to give an example, you are uploading some file to the S3 bucket. That is also an event. Suppose there is an update in the database. That is also an event, right? Or based on maybe timer also, you can create a lambda functions schedule time also. So based on the events, these functions are going to be executed. But in order to run that function or a code, you no need to have a dedicated systems running 24 bar 7. So whenever the event is getting triggered, in order to execute that function during event in AWS, this lambda can be used so that in the background, AWS will create a computing resource like a servers with the required CPU, memory, and storage, and it will execute that function in that infrastructure created by AWS in the background. And once that function is executed, the task is completed, or the function is executed, then the whatever infrastructure provisioned in the background by that cloud service provider, they will terminate. Event driven functions are triggered by events, and whenever the function is needs to be executed, that time the cloud service providers in the background create computing. Serverless, but we no need to create a servers. Basically, there are servers. Serverless cloud computing means there are servers, but we no need to have a servers make available 24 bar 7. right? Whenever that functions needs to be executed, that time this Lambda cloud function as a service model, right? They will create as computing resources and they will execute the function, and they will terminate that infrastructure after the function is getting executed. And again, when the function needs to be executed based on some event, again it will create some compute resources and it will execute that function, then it will terminate that infrastructure. So event driven functions are triggered by events, like that. And basically this function as a service is like a stateless, because it is like a temporary systems in the background in order to execute that function. So this function as a services, if you are using, they don't remember previous execution. They don't remember previous execution. Suppose you have to persist some data, you have to maintain some state or a data, you have to store that data in externalized systems like a databases, etc. And basically these functions or services is like a ephemeral. Functions will run for a short amount of time, maximum 15 minutes in AWS Lambda. This function, that code, whatever your needs to be executed based on some event, right, that will be executed for a short amount of time, maximum 15 minutes in AWS Lambda, right? And again, auto scaling, cloud provider will scale up, scale down that required infrastructure to execute that functions based on the load, like that. And again, billing is like a charged in milliseconds for execution time. So based on how many times that function is executed, based on how much, how long that how long it has taken to execute, how much time, I can say, how much time that function is executed in that Lambda. Based on that only AWS will apply the charges. It is not like 24/7 you need to have a servers, like that. And there are so many FaaS providers in AWS. There is something called AWS Lambda, that is like a function as a service. And in Azure we have something called Azure Functions. In Google Cloud we have something called Google Cloud Functions, IBM Cloud Functions, like that. Basically this you can think of AWS Lambda as a function as a service. Function as a service, it's like a serverless cloud computing model, where you will only write and deploy your code, but the required infrastructure will be provisioned in order to execute that functions. But again, it will execute, that functions will be executed based on the events. Whenever that function needs to be executed upon the event happening, right, then the cloud provider will create a required compute and execute that function or a code. Then once that execution is completed, then it will terminate that compute resources whatever it has created in the background. So you don't need to have a 24/7 dedicated systems to run some kind of a temporary task, like a batch processing, reading some kind of a files and processing the files and insert into some kind of a database, like that. I will tell you different use cases, but you can think of this Lambda like a function as a service, right? So now let's understand what is Lambda. Now let's understand what is Lambda now. So now Lambda, AWS Lambda is like a serverless event driven. AWS Lambda is like a serverless event driven computing service, event driven compute service provided by AWS. So this Lambda will allow you to run your code. That code can be developed in Java, that code can be developed in Python or Node.js, like that. It will allow you to run your code without provisioning or managing the servers. You no need to create a servers the way we have created EC2 instances, and in that servers we have deployed our code and executed our code. Instead of doing that way, you just create a Lambda function. In the background, AWS will create a required compute in order to run that function, that code. So basically, AWS Lambda is like a serverless event-driven compute service provided by Amazon Web Services. It allows you to run your code. It will allows you to run your code without provisioning or managing the server. But AWS Lambda facilitates this. You need a servers. People say Lambda is a serverless serverless concept. but there is a servers, but we no need to create the required servers to run that code, right? It will allow you to run your code without provisioning or managing the servers. AWS Lambda facilitates this by dynamically allocating a computing resources like a CPU, memory, storage to execute your functions, and only when it is needed. So AWS Lambda facilitates this by dynamically allocating a resources to execute your functions only when it is needed. Just to give an example, just to give an example, suppose you are upload, you are upload your code, your function code. Basically, you create a Lambda function in AWS. You go and create a Lambda function, and that Lambda will execute that function, that code, in response to some events. In response to some events, we already discussed about events, right? Suppose events is nothing but whatever changes happening to the resources in AWS, your AWS account. That event can be, suppose you are uploading one file to S3 bucket, that is also an event. Suppose there is some update in your DynamoDB table. Suppose you are using API gateway service. There is a one more service called API gateway. Suppose you are using a API gateway, request is coming to that API gateway, that is also an event, or it is like a scheduled job, right? So in response to the events happening in your AWS resources or applications, this function Lambda will execute that function, and whenever it needs to execute that, in the background it will create a required resources like a CPU, memory, storage, and it will run that code, and after that it will release that resources. So here it is like a serverless. Serverless means you no need to worry about underlying infrastructure. You no need to create a servers, you no need to worry about OS setup and software installation in order to run that function. Lambda, AWS Lambda will take care of that whenever it has to be executed. That time it will create the resources like CPU, memory, storage, and it will run that function. Once that function is executed completely, it will release that resources. Serverless, basically, and event driven. That code also you no need to manually trigger that function. Whatever function you need to execute, right? You no need to manually execute, event driven. So that code will run automatically when it is triggered by an event. The event is like, suppose you are uploading some files to S3 bucket, you are making some changes in your DynamoDB table, or there is a API request came to the API gateway in AWS, or based on time events also, that functions can be executed. And this is like a pay as you go model. You pay only for the compute time used by that Lambda in order to execute that function. So based on how many executions happened and how long that Lambda function took in order to execute, based on that time only the charges will be applied. So why we have to use Lambda first? Before we try to understand the use cases, why we have to use Lambda? So Lambda is like a preferred choice for many developers. Basically, developers also can use this Lambda function. So cost efficiency, scaling, flexibility, and event-driven architecture. So why we need to use this Lambda first of all? Cost efficiency. AWS will follow pay-as-you-go model. This will allow the business or organizations to pay only for the compute time consumed by their code. This AWS Lambda will charge, right? AWS will charge when we are using Lambda only for that compute time that is used by that code, whatever code it has to be executed. How much time it has taken to execute that code, only for that time only we need to pay the money. This will eliminate the need for maintaining and managing the traditional servers. So you don't need to have a dedicated systems or a containers or a clusters, right? You just execute your code whenever it is needed, and you will pay only for how much time that function is executed, only for that much amount of time. It will result in significant cost savings. And Lambda will automatically handle the provisioning. In the background, Lambda will create a required compute resources like a server, CPU, memory, storage, and the required softwares to run that function also. they will do the background, but that will be used whenever it is really needs to execute that function. After that it will terminate. And flexibility. Flexibility. So developers can use a different programming languages also. They can develop whatever function they wanted to execute, I mean to say whatever task they wanted to perform. Whatever task they wanted to perform, they can develop that task or a function in Python or Node.js or Java or more. The Lambda functions can be developed in Node.js, Java, or maybe Python, or many more, right? And again, event driven. Event driven means when that function has to be executed, when that task has to be executed, or that function, the Lambda can be triggered via various AWS services such as S3, DynamoDB, API gateway, like that. So this is ideal. You can use this Lambda for event-driven applications or event-driven architecture. Suppose if you are from a development background, you can understand event-driven applications or event-driven architecture. Suppose this is little bit development knowledge also required. Basically, as a DevOps guy also, you can use this a Lambda, or a developer also. Event-driven. That event can be time-based event, or that event can be, suppose some application is uploading file to S3 bucket. Whenever a new file is uploaded to the bucket, and you need to read that file, you need to process that file, and you need to insert that data upload in that file to some kind of a database. That is also one kind of event. Whenever a new file is uploaded to S3, or whenever any request comes to API gateway, you have to respond to that request via Lambda. Also you can do APIs, like that. So basically, event driven architecture, Lambda can be triggered by various AWS services such as S3, DynamoDB, API gateway, and many more. This Lambda is ideal for building event driven applications or event driven architecture. What are the advantages or features of Lambda? Serverless execution. As I already said, we no need to have a dedicated servers, no servers to provision or manage. AWS will automatically take care of runtime environment patching, availability, like that. Serverless. And event driven triggers. You can trigger this Lambda functions or a Lambda code, whatever code or a function you wanted to execute, that can be triggered based on events, can be triggered by over 200 plus services and custom applications also. Some examples I am giving. Suppose any file is uploaded to S3, or any file is deleted from S3, you can trigger a Lambda function and it will perform some activity based on your requirement. So what logic you are going to write in the function is based on your requirement. What logic you wanted to perform, what task you have to perform, that is based on your requirement. You can write a function, but that function can be triggered based on various events. Like suppose some file is uploaded to S3, delete, you can trigger a Lambda function, and if required, that can take the file. You need to write a code. It can read the file from S3 and it can process the file, and it, if required, it can insert into some kind of a database also. You need to write a code as a developer. So there are so many events, around 200 plus services can be trigger, can trigger the Lambda functions, like S3, maybe DynamoDB. Any new record is uploaded in DynamoDB also, if required, you can inform a Lambda to execute some task, like that. And you can suppose SNS, simple notification service, SQS, a simple queue service. Based on from these services also, you can trigger a Lambda function, like that. A trigger means like if you are from a Jenkins background, right? If you are from a CI/CD background, so whenever there is a change in the code, you are automatically, the pipeline is getting executed, right? In the pipeline, you have a commands. In the pipeline, you have a commands to take the latest code, compile the code, build the application package, deploy, like that. Similarly, you can think of these events like that only. Suppose you wanted to perform some task, you wanted to execute some code, you wanted to perform some task. Example I am just giving. Suppose someone is uploading a file to the S3 bucket, some kind of a data, maybe products data, orders data, like that. Let's imagine you are using a e-commerce application. Let's say you are a work you are you are the owner of e-commerce application like a Flipkart. Suppose in the background back office team will be there, right? Suppose some new stock came, suppose new stock came, new products came. So they are going to upload one file. Just to give an example, I am just giving an example. They are uploading a file that has like a product name, product price, product name, product price, and how much quantity, how much stock, like that, some kind of a CSV file or a excel file. Back office team, let's say there is a back office team, right, in your company. Let's say back office team, just to give an example, I am giving one use case. So there is a back office team. You are like you are running, or you are owner, or you are running one e-commerce platform, e-commerce application. There is a new products, or some products came, and some new stock came. You are preparing one kind of a report or excel sheet where like product name, product price, and how much stock came, like that like a product data. That file, let's say that products has to be listed in the actual application. That products has to be listed in the actual application. So what, let's say the back office team is uploading that file. That back office team is uploading that file, products, new products and quantity, price, like that. They are uploading that file to some kind of a folder, some kind of a folder like S3 bucket. Maybe they are uploading via another application. Maybe there is a back office application, right? Back office application, they can upload that file via that back office application. Let's say that file that is uploaded via another application is created, stored in, let's say, S3 bucket in the background. Now whenever any new file came to that S3 bucket, just to give an example, right, the back office uploaded one file to the S3 bucket, that products file, right? Then the requirement is, whenever the file is uploaded, that new products data has to be created in some kind of a database, so that this actual application is getting the products from some kind of a DB. Just to give an example. So whenever a back office team is uploading a file to the S3 bucket, only that time, maybe not every day, right? Not every day. You don't need to have a 24 bar 7, the server should be running to keep checking. You don't need to have a 24 bar 7, the servers are running. You don't need to keep checking any new file came to that S3 bucket, then read the file, insert, like that. You don't need to have such like a dedicated systems or a servers for this type of use cases. Let's say whenever a file is uploaded like this to the S3 bucket, then it can trigger a lambda function. In the lambda function, you can write a code, read that products file, read that products file, and process that data and insert the data into some kind of a products database. Then the actual application is actually pointing to that products DB and getting the products and displaying for the consumer, like a users, like that. But you don't need to have a 24 bar 7 a system for continuously checking any new file is uploaded to that bucket or some location, like that. So whenever if new file is created, you can trigger event event that event can trigger a lambda function. The lambda function can take the file, process the file, and insert into a database, like a ETL jobs. If you are from a background, if you are from a ETL background, right, those type of use cases, file processing, data processing, all those type of different use cases are there, right? So just to give an example, I have taken one use case like this, right? So the lambda can be triggered over 200 plus services and custom applications also. Any new file is uploaded to S3 or deleting, also you can trigger a lambda function, or via SNS or SQS or API gateways also can trigger. Like this, event based triggering will happen. And again, multiple language support, supports several programmatic languages. The lambda function can be created using Python code, or a Node.js, or a Java, or Go, Ruby, C Sharp, PowerShell, even a different softwares, but that can be deployed as a containers in lambda also. And again, we don't need to worry about the computing capacity, computing scaling. In order to run our function, AWS Lambda will take care in the background. And flexible execution time, right? Execution time per function is maximum 15 minutes, and it is good for short lived task and stateless task like that. And again, it is like a pay as you go, charged only based on the execution time. Based on the execution time, how much time our function is executed, only for that time only you need to pay. And based on number of requests again, and based on the memory that we are allocated, you can allocate how much memory is required in order to run that function also, you can allocate. Based on that, it will charge again. And basically each invocation or each function execution is independent, so you don't persist any data in Lambda, but that data can be maintained external in DynamoDB or RDS like that, stateless. This is like a stateless application, stateless. And we can integrate this Lambda with various other services, like, and we can directly interact with S3, DynamoDB, SNS, SQS, API gateway, or Kinesis like that. And again, you can use IAM roles and IAM policies for giving a permissions to the Lambda. Suppose via Lambda function you are trying to read something from S3, you are trying to create something in DynamoDB or RDS, the required permissions can be given to the Lambda functions or a Lambda via IAM policies, IAM roles like that. And you can directly keep your code in that AWS Lambda, or you can create as a container image and you can tell the Lambda to execute that container whenever that event is happened, container based execution, or directly you can create normal code also. Basically, these are the features. So there are various use cases. For Lambda. So basically, you wanted to run some code or some function that can be any what you are performing, what you are performing in that function, right? That is based on your requirement. But you can use for various use cases or various scenarios. So this Lambda can be used for various use cases or scenarios. Suppose, suppose just to give an example, video processing, image processing like that. Let's say automatically you have to resize the images. Automatically you have to resize the images upon upload to S3, or you have to like process some kind of a video. Suppose you are developing one social media platform, let's say you are developing some kind of a social media platform, right? And you are via your social media platform like Facebook, just to give an example, you are uploading some kind of a videos, you are uploading some kind of a photos to the Facebook, right? But in the background, let's say that Facebook can save that files to S3 bucket, but whatever file, the images or videos uploaded, it has to resize. You have to compress or resize. In that case, you can have a Lambda functions in the background, right? It will, whenever a new file is uploaded to S3, it can take that image and it can resize that image and again keep it somewhere like that. And a data transformation, suppose you are from ETL background, right? ETL background, so there is so much of data coming, you need to transform the data and store the data in some kind of a databases. Like suppose a data transformation, you can perform real-time data transformations and cleansing or cleaning the data streams from various sources like DynamoDB, or you can store in Amazon Kinesis like that also. And again, as a DevOps engineer, also you can create some kind of a Lambda function. Suppose using Boto or Boto 3, there is a frameworks like Boto or Boto 3. Suppose as a DevOps engineer, if you are you wanted to identify some servers which are in ideal, you wanted to stop or terminate the ideal servers, you can write a lambda function. I mean to say, you can write a Lambda function using a Python or Java, using a Boto 3 frameworks like that. And you can identify how many servers are there via code. I am saying you need to write a function. You can write a function like you can write a function using a Python code or a Java code. Maybe you are using Python with Boto, let's say, and you can write a code, and that code will be executed, and it can identify how many servers are there, how many servers are there, and again, and how many servers are there, and how many servers are ideal servers, and you have to stop those ideal servers, or you have to terminate those ideal servers, like that. But you can write a code, you can run that code as a cron job, or maybe one dedicated system. In one dedicated system you can create like a using Java, also Python also, you can create some kind of a jobs. But the server needs to be there 24/7, but you are running that function or that task daily only once or twice, like that. But the infrastructure charge will be more. But you can write a function, but that function can be executed based on the event, only you are charged during that time. Suppose as a DevOps engineer also, you can write some kind of a functions. You wanted to identify, you wanted to create a report, you wanted to create a report, let's say you wanted to create a report like how many servers are there daily you need a report, how many servers are there in your AWS account, and you wanted to send a email. But you can develop that using Java code, Python code, using AWS APIs. But only once you have to run that task, once you have to run that function, your requirement is, let's say you have to create a report, you have to create a report how many AWS services are there in that particular AWS account, how many servers are there, how many buckets are there, how many database instances are there, some kind of a report they need, right? In that case, you can write a code using Python, Java, using AWS APIs. This is called as a development. People call it AWS developers, right? The developers is nothing but they are developing some code, and they are performing something via code. Like people can use Python with Boto 3 frameworks, like that. So let's say you have developed one function under that using Boto or Boto 3, you are creating some kind of a report, like how many servers are there, how many load balancers are there, how many RDS are there, how many Kubernetes clusters are there, like that. You are preparing one report, and you have to send that report to some kind of a management team, some kind of a leadership in your company. But you have to run that function daily once. You have to run that code only once. That code will go through AWS account via AWS APIs, and it is taking the details. You are preparing one kind of a report, and you are sending. But you no need to have a system running 24/7 to run that task daily once. So in that type of use case, you can create that as a Lambda function, and you can schedule the Lambda functions also. Time-based event also can happen. You can schedule the Lambda function, right? Whenever that time met, right? That time AWS will Lambda will create a server in the background in order to run that function. Then it will execute that function, and once the function is getting executed, it will terminate or release that servers, like a serverless computing here. So I am like that, various use cases are there. But for now, let me take one use case. Let's say let's say let me take Rushi Technologies as an application. Let's take Rushi Technologies as an application. Let's say I have a back office team. Let's say I have hired let's say I have hired one back office team, right? Let's say I have an admin for Rushi Technologies. So let's say I have a physical training center. Let's say I have a training center located some in Bangalore somewhere. People will visit. Let's say like a students will visit the training center. They will inquire. I'm just taking one use case. Let's say people will visit to the office, right? They're inquiring like I am looking for this course, right? Let's say this admin, what she will collect one kind of a data. Okay, name, what is your name, and which course you are looking for, Just to give an example, I'm taking this use case, and let's say which course you are looking for, and again what is your phone number in case we have to contact you, and what is your email, in we will send a reminders like that. And she is capturing, just to give an example, back of this team is capturing these details like a name, course, phone number, email, like that. But I have an application already. Let's say I have an application already. Let's imagine I have an application already. This is like a dedicated application, right? Dedicated application. Let's say maybe some people are directly registering. Some people are directly registering via this application, but some people are coming to back office, I mean to say office, and they are registering offline like this. Some, but there is an application, let's say there is an application, let's say like this type of application. Let's say you take this also as an example, right? This also as an example, our website. Let's say here some people are registering. Let's say some people are registering here. Some people are registering here. Let's say like they're filling their details like this, and this is they're filling these details. I am capturing the data, and let's say I'm storing in some kind of a database. Let's say I'm storing in some kind of a database, and I'm storing some kind of a something in a database. Imagine this like this. So some people are using this application, they are registering the details, and I am storing somewhere in some kind of a database, just to give an example. And I am trying to send a reminders also. Let's imagine I have developed some kind of a task or job. I will go through this DB, and I will try to find out who registered for which course. If I have any, if I'm starting a course, batch, just next 10 days or 15 days, I can look into this DB. I can record, I can go through who has enrolled for which course. If I am starting that course within next 10 days, like every day I can go through that data, and I can send some kind of a email notifications or a WhatsApp notifications like that using some kind of a code. But some people are coming to this dedicated, here they are registering. So the admin team can create some kind of a file, kind of a Excel file like that, I told, right? Maybe that data also I have to inject here. That data also I have to store here, right? So what I can do, I can create one server, and I can run one and I can run some kind of a task in this. But this server 24/7 should be there, and this back office team is uploading that file to some common place like FTP location, or maybe S3 bucket like that. Maybe just to give an example, I'm taking one example like this back office team is uploading that every day. Every day whoever came to that training center and enrolled, right, that report she is uploading into this S3 bucket. Then the server, I can have a server, in that I can write some kind of a code that will take the file from this S3 bucket, and it will read and write into this database like that, just to give an example. But I no need to have a server running 24/7. One, like whenever any new file is uploaded here, only that time only that code has to be executed. But in order to run that code, I no need to have a dedicated server 24/7. The server should not be running, because charges will come, infrastructure charges. That is like a temporary task, only it has to execute something, and done. So in this case, what I can do, I can go and use Lambda. I can execute that code. That code will take a file from S3, and it will read that file, and it will insert into a DB like that. I can develop that code using Python, Java like that. But I can develop and I can deploy that as a Lambda function. So whenever any file is uploaded to the S3 bucket, that is also an event. That is also an event. That time S3 will trigger the Lambda function. S3 will tell, I got a new file. Now, Lambda will, you have to write a code, but Lambda will execute that function in which you have reading the file, processing the file, and inserting into a DB. This is like one use case. Like this, there are various use cases, as I already said. As a DevOps engineer, let's say you wanted to create some kind of a report. you wanted to create some kind of a report, like how many servers are there, load balancers are there, and how many Kubernetes clusters are there, some kind of a report. And you can create a report again by writing some code like a Python code, Java code. Again, that Python or a Java code internally uses AWS APIs. AWS APIs, we have something called SDK, software development kit, Lambda, this Boto 3, like that. So you can use those APIs in your code, and you can get the report, you can get the details and create a report, but only once you have to run daily. So you no need to run that code in a dedicated system running 24/7. You can create that as a Lambda function. If required, you can schedule the Lambda also based on time events, like that. So now I am just taking one use case here. Suppose just I am going to drop a CSV file. I'm going to drop one kind of a CSV file or Excel, Excel file in S3 bucket. So in my CSV file, I have something like this: name, email, course, like that. Name, email, course, phone number, whatever it is, like that. Okay. I just have a sample CSV file like this, and that we are going to upload to S3 bucket. Then Lambda can take that file from S3, and it will parse means it will process that file, and it will insert the data into some kind of a database. You can use RDS, or you can use DynamoDB, like that also, but here I am using DynamoDB. And again whether that that function is executed successfully or it is failed also, you can send some kind of a notifications also, again using SNS alerts or SNS notifications, like that. So this is what I am going to take. So here, what I am trying to design here, let's say there is an S3 bucket. In that S3 bucket, we are uploading some kind of a file. Again, in S3 also you can create an event. In S3 also you can create an event. Upon any new file is uploaded to the S3 bucket, you can create an event. That event will trigger. Event means it is like a, it will inform someone, right? So the S3 can inform the Lambda, I got a new file, you do whatever you wanted to do with this file, like that it will inform. So let's say here, this is my architecture. We are going to have an S3 bucket, and it is going to store some kind of a CSV file or XML file, like that. And this S3 can trigger a Lambda, an object created, and the Lambda will read the file, and it will parse that file, and it will insert into a DynamoDB. DynamoDB is also one service in AWS. It is like a key value pair of data. Instead of a relational database, the data will be stored in key value pairs of data, like that. And again, the Lambda can publish the summary. Summary means whether that report, that CSV file is processed successfully or failed, like that. It will publish that summary also to some kind of a email or phone, like that. But it is not mandatory to send a notifications also, but if required you can do that. If required you can do that. And whatever happening in the Lambda function, Lambda is like a serverless. You don't see any logs, you don't see any servers, you can't go inside the servers and see what happened when that code is executed. But that logs also, that Lambda will send the logs, that execution logs. That function is when it is executed, what happened, it can send that logs to the CloudWatch. All these are integrated. This is my requirement, right? Now I am going to design all these things. But this is like a development standpoint I am explaining. This is like a development standpoint I am explaining. But as a DevOps guy also, suppose you are familiar with Python programming, you can use this Lambda also for some type of your task, some type of your requirements. Like I told, right, as an AWS architect, or a AWS admin, or AWS lead, or infrastructure admin, so you need some kind of a report: servers, storage, networks, how many it is there, like that. You can also write some kind of a script that can be triggered via Lambda also, that can be executed via Lambda also, like that. But for now I'm just taking this use case so that you can understand what is this Lambda. Sometimes in the interviews they will ask what is Lambda, but you can just explain whatever I have explained here. Lambda is like a serverless, right? Why to use Lambda, advantages with Lambda, event driven architecture, like that. I have just taken so many use cases, right? You can tell this use case, but don't tell I have a training center and I have this use case like that. You can tell, maybe just to give an example, you just tell, did you use Lambda? You can say yes or no also, but if they ask what is Lambda, you can explain. But if they ask you, did you use Lambda, if required, you can say yes, and you can tell some use case, some requirement I told, like suppose you are an AWS admin or AWS architect, you need a report, or you need to identify ideal servers, and you have to stop those servers, like that. Otherwise, let's say you have some kind of a systems that has to be stopped night time and started morning time, like that, right? That time you can use directly normal EC2 instances also. You can use you can create a script, Python script using boto 3, right? You can execute one Lambda function at night time, it will stop your some servers, and again morning time again you can execute some Lambda function, it will start the servers, like that. These type of different use cases also you can use based on your requirement. But this is like a serverless. Instead of having a dedicated system to execute your code or a script, right, on whenever it is required, that time AWS Lambda will provision the required infrastructure to run these functions or a code. Once execution is done, it will terminate that infrastructure, like that. So that is actually Lambda. Now I am taking this use case with a practical example also. Now let's say I will first create a required resources. So I am trying to create an S3 bucket, and in that S3 bucket I will upload some file. But whenever the file is uploaded, the Lambda has to trigger, and the Lambda has to take that file, process the file, and insert into a database. So I need to create a DynamoDB table also, because the Lambda is going to contact a DynamoDB. It is not mandatory, but this is my requirement. According to that, I am creating all these things. And again, I am going to create a SNS topic, right, where I have to send a mail, success report or a failure report, right. Then I can create an SNS topic. Then I will create a Lambda function with required permissions. For Lambda function also you need a permissions. Lambda is also requires access to maybe S3 bucket, because the Lambda has to read the file from S3. So you, if you don't have a permissions on Lambda, S3 permissions not given to the Lambda function may not able to take the file. So here, using IAM policies, we are trying to give read access to this S3 bucket. Whatever files it is uploaded to this S3 bucket, we are giving read access, right? Similarly, we are giving write access to the DynamoDB table, because this Lambda function is going to create a data into the DynamoDB table. Again, we are giving some kind of a DynamoDB permissions. Again, we are giving SNS permissions also, because that Lambda function, this is as per the requirement. But what permissions you are going to given to the Lambda function, that is based on what services you wanted to interact in AWS again. But in my requirement, I am uploading a file to S3. Lambda has to read that file. So I am giving a S3 read permission. And again, Lambda is going to insert that data into the DynamoDB. So I am giving a permissions to DynamoDB. Again, that Lambda function, what I am developing, that is going to send a notification to the SNS. So I am giving SNS permissions, like that. This is a based on the requirement, you can give what permissions you would like to give for Lambda, right? Then I'm going to have a Lambda function. I'm going to create a Lambda function, but don't understand this code. You can't understand. This is like a Python code. This is like a Python code, right? So let me quickly explain what is there in this code. Let's say you are going to create a Lambda function. This is like your task, like a script. So here we are using Boto framework. Boto, that is one Python SDK for AWS. And using Boto, you can interact with AWS services also, like S3, SNS, DynamoDB table, like that. You can interact with this also. So here we are having the code. So here basically like a environment variables. Based on the requirement, you can write the code. So from the environment variables, it is taking DynamoDB table name, and from environment variables it is going to take your SNS topic, ARN, like that. And again, this is like one function, right? It is going to read the file from S3 bucket, right? It is reading, right? It is storing in some kind of a variable. Then it is validating whether name is there, email is there, course is there or not, like that. And if it everything is there, then it will insert that into a DB. It is going to insert that into a DB. This is like a main function. So whenever you are trying to create a Lambda function, if you are developing in Python, the function name should be like this: Lambda underscore handler. So whenever the event happened, this function will be executed. In this there is a logic. In this there is a logic, right? We are reading the objects. I mean, say we are getting the bucket name and we are getting the file name, and we are trying to read that of data from this function, and we are trying to write that data to the DynamoDB table. And again, you are preparing some kind of a report, and we are publishing it to SNS, like that. Basically, this is actual code, but don't get into this. But just I'm giving high level overview. Basically, this is what I have to run. I have to take the file from S3. I have to process that file. I have to insert into a DynamoDB table. And whether it is inserted or whether it is not inserted, I have to send a notification. So that logic is here, like that. So, but I can run this script like as a cron job or maybe some job in some server. But the server has to be there 24/7. But I don't want to do that way. I don't have a dedicated server. I can go with Lambda serverless. So whenever a file is uploaded to S3, that time it will trigger. That time only AWS will provision the server and run this code or a script or a function. Then once the execution is completed, it will release that infrastructure resources in the background. We already discussed about the characteristics of a function as a service, advantages of function as a service, like that. Like this, I can develop. So this is my requirement, and this is what this is how we are implementing, like this, right? Now let me do step by step, like a hands-on. I have given various use cases also. Based on your use cases, this code may change. This script may change, this code may change, and what permissions you are going to give to Lambda function also may change based on your requirements, like that. So for now, I have just taken one use case and I'm trying to cover this Lambda. So let's proceed now. So I will first create one S3 bucket. Let me go to one S3 bucket. Imagine this back office team has to upload file to S3 bucket, right? Then I have a Lambda. Whenever there is a new file created, it will inform Lambda. In that Lambda, I have a code, that function that will read the file, process that file, prepare the data, then it will insert the data into a DynamoDB table, and again it will inform SNS, right? SNS topic. And suppose someone subscribed that SNS topic as a email notification, they will receive email also, like this back office team or maybe any other one can receive an email, like that. This data is uploaded to this, like that. This is one use case or a requirement I have taken. So now let me implement this. Let me go to S3. Let me go to S3. I'm in a Mumbai region. Okay, you can create wherever. I'm creating one bucket. Let's imagine I will create one bucket. So bucket name you can give anything, but you already know S3 bucket name should be unique. Suppose I am giving something like this. Rushi Technologies, Lambda, ingest, or whatever. That doesn't matter. Suppose I'm giving like this. If this with this name, if this bucket is already there, you have to create a bucket with a different name. Suppose AWS Lambda ingest, like that. You can give something, right? You create a bucket. You create a bucket. Now I have this Lambda code. This Lambda code is trying to read the data is trying to read the data from a specific location, I am going to create a folder also inside this. I am going to create a folder also inside this, right? I am going to create a folder also inside this, like a input folder. There we are uploading the file like that. Otherwise, you can directly also upload. Otherwise, like a folder name is input. Like you can say here, create folder. You can go to this bucket. You can go to this bucket. Here there is something called create folder. I am creating a folder called input. Suppose if you are practicing this, you can have a bucket different with a different name. Because I already have a bucket with this name. If you try to create in your account, it may not work, right? You can have a different name. But in that bucket, I am creating one folder called input. Okay. I will upload the file later. I will upload the file later. Step by step, we are going. So first, I have created a bucket. I have created a bucket, right? And in that, I have created a folder with this name. But the event I will create later. First, after creating a Lambda function, in this bucket, I will create an event. Whenever an object is uploaded to this bucket in the folder, I will create an event that has to inform Lambda, event-based application, event-based architecture. So I will create an event once Lambda is created. For now, we just create this bucket, and in that have folder. Now I will create a DynamoDB table also, because the Lambda function is going to create a data into a DynamoDB table. That is my requirement. So it is not mandatory that you have to have a DynamoDB table for Lambda. So my requirement, according to my requirement, I am creating a DynamoDB table where it will store that data. Suppose this is again one more service. I will go to DynamoDB. I will go to DynamoDB. I will create table. I will give name, same name, because in the code we are using all these things. If you see here, using Boto, we are trying to contact DynamoDB, and here the table name is provided as an environment variable, but maybe when you are setting the environment variables for this DynamoDB, I mean to say this Lambda also you can give, but let me give the table name as like a registrations or something like this meaningful name, registrations. And here this is DynamoDB partition key, like a primary key. Here I'm giving email as a partition key, like unique. There is a white space, remove that white space before or after. And the sort key I am giving like a course. One person can register for multiple courses, so email is this, like this partition key, sort key, like that we have given. So with this, I am creating a DynamoDB table. With this, I'm creating a DynamoDB table. Basically, it is a capacity type only, on demand only by default. Let's create a DynamoDB table. Now there is a table, but we don't have a data. So if required, here you can go to this. Once the table is created, DynamoDB table, you can go to this and you can see explore table items, like that. I don't have any records as of now, but it will come via Lambda, right? I have created an S3 bucket. I have created a DynamoDB table. Now I will create a SNS topics also, because via Lambda function, I am going to send a report. That is my requirement. According to that only, I am using all these services. So let's go and create a topic and let's subscribe, email subscription, like that. So that the Lambda will send a notification to the SNS. Then SNS with some message, and whoever subscribed, then they will receive a mail, like that. So this is SNS service, different service, but I am not covering SNS in a detailed way here. But let's go to SNS. So let's create a topic. I am creating a topic. So standard topic, I can give some name. That can be any name. Suppose something like this. Any name you can give. That doesn't matter. You can give any name like that. and a display name also this, create a topic. Now under this topic, I will create a subscription, subscriber like that. So let's create a subscription for this topic. Protocol email. Let's say I will give this as an endpoint. Protocol I'm taking email because I wanted to send a notification, email notification. There are so many protocols this SNS will support, but we are not focusing on that. Let's say SNS email. This is my email. So let's create a subscription for that topic. But this you already know, previously also we discussed, right? This is going to be in a pending for confirmation. You have to confirm that you will get a mail. So I have given this only as a mail ID. I will go to my Gmail, personal mail IDs I am using, and I will confirm this subscription. Okay. Now this is also done. This is also done. Let's refresh. Let's refresh. This is also done. Right? Confirm, subscription is confirmed. Now next what we will do, we will create a IAM roles, required IAM role to attach to the Lambda function. So basically Lambda requires this AWS Lambda basic execution role. First one policy, this policy is required because in order for Lambda to send the logs to the CloudWatch, we need this permission. And again these are custom permissions or custom policies, right? That is based on your requirement. So let me create one IAM role. So if you are not familiar about what is IAM, users, groups, roles, policies, user defined policy, or a customer managed policy, or AWS managed policy, in our YouTube channel there is a dedicated video right here. I hope you guys went through already. If not, go through this video. AWS IAM and CLI. There is a more than 2 hours video, detailed video, where I have explained the concepts of IAM. Very, very important. So you can go through this in our YouTube channel if you don't know what is IAM again. So now I have to create a IAM role for that Lambda to give for giving a required permissions to the Lambda function. So let me go to IAM. Let me go to the roles. I will create one role. I will create one role. The role trusted entity type, for what service you wanted to attach this role. Now I wanted to attach this role to the Lambda. I am selecting Lambda. Allow Lambda functions to talk to other AWS services on behalf. That's what I have selected, Lambda. I want to attach this role. You can give some policy. Already there is a AWS managed policy. This is one policy, AWS Lambda basic execution role. So based on your requirement, you can give any other permissions also. But let me search with the AWS Lambda basic execution role. If you have any white spaces also, it will not match. So in this, we have some limited permission, CloudWatch permissions only there, so that Lambda can send the logs to the CloudWatch like that. I have selected. Click on next. Here you can give some name, that any name you can give. Suppose just to give an example, I am giving this as a name. Like that. You can give any name. This is like a role name. That role has only this policy, and you need another policy also. You need one more policy, some other permissions. That permissions again you can attach. In AWS there is something called inline policy. You can go to this IAM role. Whatever we have created, and here add permission. You can create a inline policies also. Otherwise you can create a custom policy and attach that policy. This is IAM concept. But I need to give some additional permissions. So this is just a syntax, guys. You have to replace here so many things if you are practicing. Let's say this is additional permissions I need. So here make sure you give your bucket name. You are giving for Lambda, for Lambda, you have to give a permissions to the S3 bucket in order to read the files. So here you give your bucket ARN. This is like a folder. In that folder only I'm going to upload that files, right? Let's go to S3. Let's go to S3. This bucket, this folder, like that. Here you can take ARN. You can go to the properties of this. You go to bucket and you go inside this folder also. You can go to the properties. This is like a ARN, your bucket ARN. So make sure you give it correctly. But a forward slash star is required because we are giving permissions to the files that is uploaded to this bucket in this folder, like that. These permissions. Then database, that are DynamoDB. So here you have, these are the permissions. These are the permissions you have to give. But for which DynamoDB table? There are so many DynamoDB tables. So here this is like a syntax, but you have to replace. Go to DynamoDB. Go to your table. This is the table. You can see there is something called ARN, Amazon Resource Name, a unique way to identify. So this is what I am giving. So here basically account ID. This is like a table name. This is in that table is in this region, like that. That is the ARN. Similarly, I need to give permissions to the Lambda to in order to talk to the SNS for sending a notification. So similarly, you can go to SNS. And here this is the SNS topic that I have to inform. This is the ARN. You copy this and update here, like this, right? This is one kind of a policy. So this you can attach to that IAM role as an inline policy. You can attach that policy as an inline policy to that role. Otherwise, you can create a custom policy, user defined policy, and attach. It's up to you. It's up to you. Suppose you can directly do like this also to that role. That role you can go and attach as an inline policy. Create inline policy, JSON option, delete this, paste, like this also you can do. Like this you can do basically. Policy name is required. You can give some name. Maybe name. You can give some name like SNS S3 DynamoDB. Something like this. You can give some name. Attach that policy. Now this policy is attached, but inline policy, like that. Otherwise, there is a different way also, that is IAM concept. You can create a policy. You can go to policy like this, go to JSON, you can paste that and create as a custom policy that you can attach. But for now, I have just given as an inline policy, that is fine. This is IAM concepts. Now there is a role. There is a role that I have created. This role I wanted to attach to the Lambda. That's what I have selected. This role has a policies attached. Required policies as per my requirement. Also I have attached. Now this role I will use when I create a Lambda function. Now let's go and create a Lambda function. Let's go and create a Lambda function. Let's go and create a Lambda function. I will go to the services. Let's say Lambda. Lambda. Run code without thinking about servers. You can see the tag like a subtitle for Lambda. Run the code without thinking about servers. So you no need to create any servers to run your code. In the background, AWS will provision. This is like a serverless. There are servers, but it is like a serverless. But who is going to create the servers in order to run that code? Again, AWS only will create. And once the code is executed, it will release that servers in the background. The charges are less, as I already said. So let me go to Lambda. Let me go to Lambda. Here, Lambda supports .NET, Java, Node.js, Python, like that. If you see, this is like a simple they are giving. Simple, like a hello world. This is just they are showing, but how I will create a dedicated function. But here they are showing how it works. This is like a name, right? In this function, whatever you are going to have, it will execute. This is like a hello world. If you, this is like a testing only. If you run this also, you can see in the background, hello, this output came. This is like a hello world example they are giving. Suppose if you are from Java background, you can use this AWS APIs, AWS framework or AWS libraries also. You can implement these like this, and you can do something like this here. But for now, we will use Python. But this is not hello world example I am taking. This is like a real code. So here I am using so many services also, event driven, all these things. First, let me go here, create a function, create a function. So author from scratch, I am taking this author from scratch like that. And here I will give some name. You can give any name. Maybe you can give any name that is like a your lambda function name. Maybe here you can give any name, but I am just giving something like this: CSV to DynamoDB, RS3 to DynamoDB, like that. And here, on what runtime, on what runtime your code should be executed. So this is based on your requirement. Here you can see, choose the language to use to write your function, like that. So here I am not using node.js, I am using Python. So I am selecting this Python 3.1.3, like that. But it can be 3.1.3 or 3.1.2, whatever it is, it's up to you, like this. And in the background, servers will be created. So choose the instructions to set the architecture, basically on what type of system, ARM processors or AMD processors has to be used in order to run this code in the background. So I'm just taking this. And here, permissions, permissions. Here I will expand this. Here I will attach an existing role, whatever IAM role I have created with some permissions. I will go with this, use existing role, and I will attach this role, whatever I have created with some permissions to this, like this. Here I'm creating a function with this. Still, we need to define the code. I will define that. First, let me create a function like this. So if required, you can follow this also. I have selected author from scratch. This is the name. Runtime, I have selected this. This is the role. Then click on create function. Create function this. Create function. The code will accept, ignore, accept. So here the code I will copy paste. But make sure you copy paste syntactically without any problem. I am taking here. If required, we can make this. You can, like this. I am just taking. Okay, fine. Now I will just copy paste this code and make sure there is a function with this name, lambda underscore handler, in case of Python, right? So this is like a main function that is going to be executed when we are running this lambda function. But I no need to manually run this function. This will be triggered. This lambda function can be triggered from various services based on the events also. I just pasted that code. I just pasted that code, and I will just click on deploy. I will just click on deploy. I will just click on deploy. But before that, I have to set so many things. I have not set. Okay, I will do this later. Before that, I have to set environment variables, because in this code you can see I am reading an environment. From environment variable, I am trying to get the DynamoDB table name, and I am trying to get that SNS ARN also, because I am using this in this code. Here you can see I am publishing that message to the SNS, that report, success report or a failure report, like that. And also I am contacting DynamoDB table, and I am trying to insert DB. So I need those details before I create this lambda function, right? What I will do, you can do this way also. You can paste here, and you can see configuration options. You can paste, and you can go to configuration options here. Here you can edit the time also, because it will take time for running this configuration. General configuration you can edit. like for me, I'm giving minimum time like a 1 minute timeout. And here this is already attached. And how much memory is required in our turn. You can do this for now I'm giving 5 megabytes. And how much is required for the function to execute. I'm giving like this, right? 512 like that. Okay. Now these are like a general settings. I'm trying to click in this configuration only. You can set environment variables also. In this configuration only, you can set environment variables also, like that environment variables, right? I will set the environment variables also, like here it is the code is expecting some environment variables. So in the general configuration, I have increased the timeout and the memory based on this requirements, like that you can define. And here environment variables also you can set environment variables, edit, then add environment variable. One of the environment variable that is referred in that Lambda code is table name. So I am giving table name. The table is the registrations, the DynamoDB table name. I have created a DynamoDB table with this name, right? So registration. And one more environment variable according to your code. This is SNS in order to send a notification. So that you take properly give. Anyhow, I have already have here. I'm giving this ARN like this. Save this environment variables. Now you go to code. You go to code. I have pasted the code already. I have pasted the code. After pasting that code, right? Let's deploy. Just click on this deploy. But now there is no servers created in the background. There is no servers created. I have just created a Lambda function. But whenever an event happened, that time it will trigger. So there are various ways you can inform the Lambda to run this function. So now my use case is this. I am trying to upload one file to S3 bucket, and in that I can create an event whenever any objects uploaded to S3 specific file or a specific pattern. It has to inform Lambda like that. So I will create that event in my S3 now. So after pasting this code, after doing all these things, now I will go to S3. We are linking S3 and Lambda together. So I will create a notifications, event notifications. So in that Lambda. So let me go to S3. In the S3, I am going to create an event. Now I will upload the file also after creating an event. So let me go to this bucket. Here, let me go to properties. Here, let's go to this bucket. Let's go to properties. Here, if you scroll down, there is so many things also. Here, there is something called event notification. Event notification means you can, any event happen in this bucket, you wanted to notify some other AWS service like that. So here I will create a event notification. I will create a event notification. So you can give any name, event name, anything you can give. Suppose something like this. You can give any name, that doesn't matter. And again, and what objects you wanted to create an event. I'm saying in this inputs folder, I'm saying prefix like inputs. In that inputs folder, if there is any CSV file will come like .csv like that. I'm limiting. So that event has to inform Lambda only when any CSV file is uploaded. I have given .csv, and in this folder, any .csv file is uploaded. That time only that this event has to be triggered. Like this, I have given prefix inputs / suffix .csv like that. Then here on what okay. Here I will select like all object create events. Whenever an object created, I don't want to trigger this event based on whenever we are removing the object. I just selected based on my requirement. whenever any object is created in this bucket, in this folder, again that CSV object, CSV file, that time only that I wanted to trigger a event. So I have selected like this, all object create events, event name, prefix, suffix. I have selected this. If you scroll down, to whom you wanted to inform, to whom, here in the destination, to whom, here I have selected destination as a lambda, and again I already have a lambda, so I will select this lambda. In from this drop down, I will select this function. So this is like an event I am creating. So whenever any file is uploaded to the S3 bucket, a CSV file in this S3 bucket in this folder, whenever any new object is created in this bucket in this folder, again .csv file, we are informing this lambda function. So this is like an event. So any file is uploaded to that S3 bucket, this lambda is going to be notified, and that lambda function will be executed. In that lambda function, I have a code, read that CSV file, talk to the DynamoDB and create the records and send a notification like that. So let's save this event. Now, let me, before I practically demonstrate, if I go to this bucket, in this folder, I don't have any file still, CSV file again. And if I go to DynamoDB table also, let me duplicate. Let me go to DynamoDB table. So I will go to this tables. If you see in this table, we don't have explore table items. We don't have any records still. And I have a lambda function also. I have a lambda function that is linked. Let me duplicate. But there is no server now. There is no dedicated servers. But this will be executed. This will be executed based on the event. This is going to be executed. Here you can see what and all things are happening. So here S3 is going to inform this function like that. You can see here. So this is like a trigger. You can see here, right? Now I no need to manually trigger. I have created an event in this S3, right? So whenever any file is uploaded, it will inform this lambda. But in order to run this function, this code, we don't have a dedicated server. We don't have a dedicated computing resources like a server with a CPU, memory, storage. But that will be created when it is needed, and it will execute that function, and it will terminate that resources like that. Serverless, basically. Now let me upload some file. Maybe let me, I have a sample file also already. Maybe I have a sample file, like a sample file also I have already. Let's say name, email, course. This is expected format. Otherwise, if you pass in a different format, the code will not understand, because this is the requirement only, the code is developed. Code pasted, right? So here you can see name, email, course. That is like headers. And again, there we are processing. If there is no headers with this, we are throwing errors also like this. And again, we are each row, this is expected like that. We have that logic here. So I have a sample file. Let's say this back office team, back office team is having some kind of a file like a CSV file or XML file like that. Here someone came and registered, inquired. Let's say someone like let's say Rutvik, comma separated values. He came, and this is the email ID of that person. The back office team has collected. Let's say I'm just taking a real use case or a real time example like that. And he is looking for some course like maybe Azure. Let's say one more person also inquired, like, and again, this is the mail ID. Imagine he has given, and he is looking for let's say some course like DevOps. Just to give an example, this is like a sample file back office team having. They can upload this file via other applications, but we don't have all those applications. For now, let's say I am directly uploading this file to that S3 bucket. I am directly uploading this file to S3 bucket. So this is the bucket. This is the bucket. In this bucket, in this folder, I am going to upload, add file. Let's say this is the sample file that I have in my laptop. Already I have saved like a sample.csv. That file name can be anything, but it is a CSV file. I am uploading that file to S3 bucket. And we have created an event based on the object creation. That event, now we have created an event here in this S3 to inform Lambda. Now the S3 has informed Lambda now. That S3 has informed Lambda now, right? Now there is no server, but Lambda internally created a required compute and it has executed that function. As per the code, basically this data has to be reflected in this this data has to be reflected in this DynamoDB table. Last time I don't have a data. Now let me refresh here. Let me click refresh here. You should be able to see some data unless until there is a failure. I think I don't see data. There is something wrong in my setup, but we will troubleshoot. Let's say I will go to this explore tables. I don't see any data, but let me go to Lambda. Here we have defined the code, everything correct, define the code, but you don't see a server. But how you can troubleshoot? This is, there is no dedicated server here. You don't have a EC2 instance in that it is running, but this Lambda will send the logs to the CloudWatch. But I should have received some email on failure also, if it is some problem. Okay, I didn't receive, so something wrong with that syntax itself. But let me go and troubleshoot. Let me go to CloudWatch. Already Lambda is integrated with CloudWatch. Let me go to CloudWatch. Sorry, CloudWatch. So here you can go to log groups. Already there is a group might be created. One second. So one second. Is there any mistake I have done? One second. The Lambda. Did I click on that deploy? So basically, sorry guys, here there is a syntax problem. I have to delete this, but I have not deleted. I got the problem. The Lambda function syntax itself is problem. You can update this code anytime. Let's there is a problem with this code actually. So when I have pasted, I have not cleaned up the previously sample there was giving. So this was the problem. So now let me update this code. You can update this Lambda function anytime. Again, do deploy. Now now this is fine. This is fine. Now this is fine. But maybe in order to test, what I will do, again I will upload the same file, or maybe you will upload the new file. But already event happened. That time it is failed. That time it is failed. Ideally it should reflect in CloudWatch. Ideally it should reflect in CloudWatch. I think the syntax problem is there. That time it was not created a log groups also. That time it has, I think, not created a log groups also. Now let's say I have updated that Lambda function properly. There was a syntax issue that I have fixed. When I copy pasted here the code, in the beginning I have something that I have removed now and I have pasted. Now I have given all the details also here, like configuration. I have given environment variables, right? And again, general configuration, I have given required memory like this. Okay, now let's go and upload a file to S3 bucket, maybe with same name or a different name. You can upload same name or a different name also, you can upload. So now let's go to S3. I will upload again, because that I have to trigger as an event, right? That Lambda will be executed upon new object creation. Last time it might be triggered, but there is a syntax problem. Let me add again. maybe same data, that CSV file, upload. Now, I hope this will work fine now. We have uploaded a file with same name or a different name also, but make sure it is a CSV file in that. But I have given input, but in the events I have given inputs, I think. Sorry. When I am creating an event here in this bucket properties, in this bucket properties, event on inputs, actually it is not. I have a folder with input, but it is not on inputs. So event also will not trigger now. It will not trigger Lambda because I have wrongly defined here, just input, not inputs. Okay, let me update this event. I mean, so this event creation. So this is like a troubleshooting, the also, right? The small mistakes also it will happen. You might be thinking I am uploading a file to this bucket in this folder, but the Lambda function is not getting triggered. I have wrongly created an event. So that's why now I have corrected. Again, let me re-upload. I have done some mistakes in event creation, Lambda function creation also, but you can understand the troubleshooting also. Let me re-upload. This time, hope the Lambda is going to be triggered because I have created an event. Now let me go to DynamoDB table again. Let me go to DynamoDB table. Let me go to tables. This table. Now explore items, table items. Yeah, you should see the data now. Last time there was two mistakes. One is when I was pasting the Lambda function code, there is some additional lines in the beginning that I have removed and pasted. Again, there is a mistake in event creation also, right? But I have corrected both and I have uploaded. Now you can see there is a data in this DynamoDB table. So again, let me upload one more file so that you can understand. Let's say the file name no need to be sample.csv like that. Maybe let's take maybe any name. Let's say on next day some other people came and these guys also inquired for some training. Let's say these guys are inquired for some training, just to give an example. And this is like a CSV file. Let's say these persons like that. I am going to save this as a different name. That can be any name. Suppose register inquiries, course inquiries, or something that doesn't matter. Course inquiries. Date also you can mention. Maybe today's date, like a 16th September 2025. .csv file. .csv. This is like a CSV file extension. Like this is one CSV file, let's say. This back office team again uploading that file to that S3 bucket. Let's imagine. Again, they are uploading with same name. They can replace also. Just to give an example, I am again uploading this file, CSV file, in the same bucket in that input folder. And there is an event created already in S3. Any file created in this bucket in this folder, again .csv like that, a event will be triggered to the Lambda. Again, Lambda will execute that function. In that function, there is a code. It will read this file, process the file, insert into a DynamoDB. Again, let me go to DynamoDB. Let me refresh here. You should be able to see additional data. You can see Hemant like this. But where is the servers? Where is the servers where the code is getting executed? That servers are like a managed in the background by Lambda, right? Serverless computing. And we have already configured a notifications also. I got a notifications like last time 2 records processed. Again, this time 2 records processed. Like that, I got a notifications also. This is how the Lambda can be used. But I have just taken one use case, but this Lambda can be used for any of your use cases. Serverless computing. I have explained so many use cases. I hope you are clear about this Lambda also. I try to explain as much as possible, as detailed as possible, with all the possibilities, use cases, and how all these things can be wired together also. Right. Thank you. I hope you guys understood what is actually this AWS Lambda. What do you mean by this function as a service or a serverless computing?